Hi, welcome to Easy Exposure in a new year 2013. Happy New Year to all of you. I hope your 2012 was great and 2013 will be even better. Let all your dreams and plans come true. And I also want to make a special shout out to all of you who I got chance to get to know on our Easy Exposure forum. And you probably know who you are. And I just want to name few names, those people who spend a lot of time on our forum, and we made our own little community out there. So special shout out to Ron Akamandrake. I hope I pronounced it right. I think without him our forum wouldn't be the same. Thank you for posting on almost every post and giving great comments and advices, and also even taking their own look and take on other pictures and adjusting them. I think it's great. Ron, keep on doing that. We love to have you on our forum. Also, I would like to say hi to Patrick Akasilke. We like your all posts and comments as well. Also, thank you to and Happy New Year to Daniela from Portugal. As you can see, we have people from all over the place. To Dale from Canada, also to Iwan, and also Interhab, and of course to our Alexander, who is our Photoshop pro. We love your pictures. We love all the pictures you post and all the manipulations, and you show how you have fun with your kids. Your Happy New Year to your family and your daughters. They're beautiful. And also Happy New Year to Dansari, and also to Victor from Singapore. Oh my gosh, Singapore is such a beautiful country. I love to see all the photos he's posting. If I forgot somebody's name and didn't mention, the list can go on and on and on, but you know who you are, and we are happy to have you on our forum. And those of you who are not on our forum yet, please come and join our community. We have a lot of fun, and there's so many people from different countries who share the culture, and I think it's just great that with this age of internet we have this possibility. We can discover different places, different people, without even ever see them in person. But let's go back to the studying and lesson. For you, I have today a new lesson. I didn't post it any lessons for a while because I was super busy. Sorry about that, but I will pick up now and you will get more new lessons from me. So this lesson is about depth of field, but we were talking about depth of field in my previous lessons. So if you want to refresh your memory a little bit more, watch one of my previous lessons about depth of field. But this one will be a little bit more in depth, and I will show you some tools which help you to measure depth of field. And also we will be talking about hyperfocal distance, which is very useful when you want to get a maximum depth of field, and it's very useful when you're taking pictures of landscapes. So let's get started. Let's refresh our memory on what the depth of field is. And depth of field is a distance between the nearest and the furthest object in the scene, what appears sharp or in focus in the image. Like in this image, for example, we are focusing on the eyes, so eyes are our focusing point. And as you can see, a certain amount of the scene, certain distance in front of the eyes, which is closer to the camera, is in focus, and also certain part of the scene behind the eyes, which is further from the camera, is in focus. So this distance between nearest and furthest object to the camera in the scene which appears sharp or in focus in the image is our depth of field. So you can see our depth of field between those two red lines in this image. And our depth of field depends on the following factors. And those are aperture, And the wider the aperture, the less depth of field you get, the narrower depth of field will be. And the smaller the aperture opening, the more depth of field you get, the more scene will be in focus. It also depends on the focal length of the lens. The longer the lens, the more focal length you have, the less depth of field you get. And the shorter the lens, the less focal length of the lens is, the more depth of field you get, the more things will be in focus in the scene. It also depends on the distance to the subject. The closer to the subject you are, the smaller the distance to the subject is, the less depth of field you get. And the bigger distance to the subject, the further from the subject you are, the more depth of field you get. And also it depends on your camera sensor. Usually the smaller the sensor, the more depth of field you get, and the bigger the sensor, the less depth of field you get. But is it actually possible to know exactly how much depth of field you are getting? Yes, it is possible. There is a special formula which lets you to count how much depth of field you are getting. But we're not going to talk about formula itself. I will show you the tool, the special program, which helps you to count your depth of field depending on the type of your camera, your aperture, focal length, and your distance to the subject, your focusing distance. So let's look at the tool. And this tool called depth of field calculator, and you can find quite a few of them on the web, and also there are apps you can download to your phone. And one I use is the depth of field masters depth of field calculator, and you can find it on dofmasters.com, or you can also find the app for your iPhone or your Android phone. But there is also others you can try out. Just type depth of field calculator in the search and you can find a whole bunch of them. And to calculate your depth of field, as we already mentioned, depth of field depends on the camera and mainly on the camera sensor. Either is full sensor or crop sensor, and you will have to choose type of your camera right here, and we will just choose Nikon D7000. But if you go, if you get the app, you don't really have this all choices of the different Nikon cameras. All you have is just Nikon DSLR or Nikon D3, and Nikon DSLR referred to all the crop sensor cameras, and Nikon D3 referred to all full sensor cameras. So it will be the same for D800, D700, and D3, so you can just choose this one on the app. But for now, let's, for example, choose D7000. Also, there is different type of camera. There is for Canon, Fujifilm, Leica, all type of cameras right here. So let's choose this one. Also, depth of field depends on the focal length of the lens. So let's choose just 50mm lens. Also, our f-stop, let's choose, let's say, f5.6. And also our distance to the subject. And you can measure distance in a different measurement, because in Europe people measure everything in meters and centimeters. Here in US they measure it in inches and feet. So let's, for example, choose feet, and let's assume we are 5 feet away from our subject. So we calculate, and it will show you that we are 5 feet away from our subject, and our depth of field will be 0.67 feet. So can you imagine how much it is approximately, our depth of field? And also we can see that where our nearest limit and furthest limit from the camera, where our depth of field is. And also it tells you how much depth of field is in front of our subject and behind our subject. In most situations you have a little bit less depth of field in front of the subject than behind of the subject. It also tells you what your hyperfocal distance is, but we will talk about hyperfocal distance a little bit later. But to prove you that our depth of field depends on focal length, f-stop, and distance to the subject, let's try to play with those numbers. So remember, at 50 millimeters, the focal length of the lens, we have our depth of field as 0.67 feet. But what if we increase our focal length and let's say we go to 85 millimeters? Our lens is longer now, and as you see, our depth of field got narrower. But if we go opposite and let's say we use 35 millimeter lens, our depth of field is wider. It's already 1.4 feet. The same is with f-stop. Let's say now we're at 5.6, but what if we go and our depth of field is 1.4 feet? But if we go to, let's say, f1.4, our depth of field got smaller. Or if we go to let's say f16, we got 4.58 feet of depth of field. And the same with our distance. Let's say now we at 5 feet to the subject, but what if we get closer and we'll be like 2 feet from the subject? If we're closer to the subject, our depth of field is narrower. And then if we go to, let's say, 10 feet from the subject, our depth of field is 41 feet right now. So you can play with those numbers and see how your depth of field is changing depending what settings you have in your camera. What is your focal length, what is your f-stop, and what is your distance to the subject. And now let's talk about hyperfocal distance. So what is the hyperfocal distance? If you focus on hyperfocal distance, everything from the half of the hyperfocal distance to infinity will be in focus. Let's look at the image and let's assume that your hyperfocal distance is 5 feet from the camera, which is signed with a red line on the picture. This means that if you focus on your hyperfocal distance, your nearest limit of accessible sharpness will be 2.5 feet from the camera, which is half of your hyperfocal distance. It's assigned with blue line on the image. And this means that when you focus on your hyperfocal distance, everything from 2.5 feet from the camera all the way to infinity will be sharp or in focus. So let's go back to our diagram, to our depth of field calculator. And with focal length of 35 millimeters at f16, our hyperfocal distance will be 12.7 feet. So if, for example, we put 12.7 feet here, our distance to the subject, our focusing distance, you can see that everything from 6.34 feet all the way to infinity will be in focus. And also when we increase our distance, let's say 14, still everything to infinity will be in focus. 18, it's just the nearest limit of your focus will be further. The more we're increasing it, this limit is increasing, but it's still gonna be all the way to infinity. But if we go below our focal distance, let's say like 11, our far limit is not infinity anymore. And the wider aperture you use, the further the hyperfocal distance will be. So let's say if we go to f11, your hyperfocal distance will be at 17.9, But if we go to f22, your hyperfocal distance will be just 9 feet. Also, if we will change our focal lengths, if we, for example, go to 50 millimeter lens, our hyperfocal distance will be further from us. Or if we use, let's say, 20 millimeter lens, our hyperfocal distance will be close to us. So it's easier to get more stuff in focus with a shorter length. So how do you actually focus on hyperfocal distance? Actually, some of the lenses have a scale, a focusing scale, and even hyperfocal distance scale. So let's take a look at the lenses. Okay, a lot of lenses have this scale which shows you your focusing distance. So when I'm rotating the focusing ring, it's changing, and it's also, you can see it's in feet and meters. And for example, now I'm focused at 1.75 feet, at 2 feet, 2.5 feet, 3 feet, 4 feet, 7 feet, and 20 feet. Unfortunately, it doesn't show you every number, so you kind of have to guess where, for example, 10 is, but I would assume it's somewhere around here if I want to focus on the 10 feet. But it gives you an approximate idea about that. And then it goes all the way to 20, and then we have an infinity. Also, this will show you what your depth of field is. Let's assume these numbers mean your f-stop. And some lenses have more f-stops, some less. It can be like because this lens goes only till f16, so there is no 22 here. Some lenses have also f8, but this one has only f16 and f11. And let's say I'm focusing at 4 feet. So, and my f-stop is f16, so it means that my depth of field will be approximately, I would assume, if it's between 3 and 4, around a little bit more than from 3 feet from the camera till probably around 5 feet from the camera. Of course, this is not 100% accurate because you can't see those numbers in between, but it will give you a little bit of an idea. But, I mean, the main thing which is very helpful with this scale is that you can find your hyperfocal distance easily. So let's say if your f-stop is f16, if you put your f16 right here on infinity sign, it means you're focusing on your hyperfocal distance. Or let's say you're shooting at f11, if you put 11 at infinity sign, it means you're shooting at your hyperfocal distance. I think this is the main thing which is the most helpful of this scale. But unfortunately, a lot of new lenses don't have this scale anymore. They only have this one. This scale is mostly old the lenses which were used with film cameras have this scale. Like as you can see, this lens only has the scale which shows you your focusing distance, but you can't really see where your hyperfocal distance is. And there are some lenses which don't even have that scale, nowhere. But what to do if your lens doesn't have a scale, focusing scale? Well, there is a device which called laser ranger, and it's like a little device which has a laser inside, and you can point it on the object and will tell you the distance to the object. But those are not that cheap. You can look them up online. I just wanted to tell you about them. It's an interesting device, maybe for those of you who shoot a lot of landscapes and want to get those great Ansel Adams looking photos with a depth of field from beginning to the end, it might be useful. Also, if you don't have a Ranger and your lens doesn't have a scale, you can kind of eyeball it. Eyeball your distance to the subject and focus on the subject which you think is at your hyperfocal distance. This way you get the widest depth of field. Also, it's better to focus a little bit past the hyperfocal distance, because then for sure your depth of field will spread to infinity. Also, you can calculate your f-stop and then close down one f-stop just to be sure. But why is it important to have to know about hyperfocal distance? Is because you don't want to always use your smallest like the biggest f-stop, which is smallest aperture opening, because most lenses don't perform their best at the smallest aperture opening. They're not the sharpest as the smallest aperture opening. They also can have some vignetting around them, so they're not the best performers. So you want to open up your aperture a little bit and shoot landscapes at least at f11, maybe f16. Don't go like past 22, 32, because those f-stops are not the best and will get you not the best results. But knowing your hyperfocal distance, f11, in some cases even f8, can give you a satisfactory results where you can still get this wide depth of field. I hope this lesson was helpful to you, and now I would recommend you to go and play with this depth of field calculator and see what results you have. Just try to put in different numbers and see how your depth of field changes depending on which focal length you use, how far from the subject you are, or which aperture you use. Of course, I'm not telling you to take every picture by using the calculator. You will have no time, but just to check it out and see how all the things like aperture, focal length, distance work between each other and how they influence depth of field, I think it will be very helpful for you, just to get this general idea. Of course, for example, if you're taking picture of the person and you want the whole person in focus and you taking picture at 1.8 and you see that your depth of field is less than an inch, obviously you're not gonna get the whole person in focus, but just maybe eyes or a nose. So you want to find that perfect number which will give you maybe at least a foot of depth of field. Or when you take a family portraits, very often people ask me, what f-stop do you use to take a family portrait? So go check it out, the calculator, and see how much do you need, how much depth of field do you need to take a family portrait. If you put people in a rows, probably maybe 3 feet. It depends how close to each other they are, but for family portrait you want to put people as close to each other as possible. It's not because only of depth of field, because you want to get everybody in focus, but also the subjects which are closer to the camera appear bigger than the subjects which are further from the camera. Also, as I already told you, how hyperfocal distance is very useful for landscapes, and you don't have to take a picture of the landscape always at the smallest aperture, because smallest aperture is not the best aperture, it's not the sharpest aperture in the lens, and you can get better results with shooting with a little bit more wider aperture. Your picture is gonna be sharper, but by using hyperfocal distance you still can get everything you desire in focus, and Ansel Adams will be proud of you. So I'm looking forward to a new lesson. Happy New Year again, and see you next time. Bye-bye.